This is experiment 10, mode frequency analysis of beams. One cantilever beam, another one simply supported beam. Okay. So next you see the experiment. So first aim of this 10th experiment is mode frequency analysis of following beams. First one cantilever beam, second one simply supported beam. So this property is 10 cross 10 cross section, and Young's modulus is 2.1 into 10 power 5 Newton per mm square. Poisson ratio is 0.3, and then density is 7830 kg per meter cube. This is for steel. Then frequency is 100 hertz. Okay, so this is the given parameter. So next one diagram. This is the simply supported beam. So we know about simply supported cantilever beam. That cantilever beam one end is fixed, another one is free. For simply supported beam, two ends are hinged uh, portion. So cross section both are uniform, 10 cross 10. So length is 1000 mm. Okay, so this is our model analysis diagram and material properties. So then you have to answers. Go for answers. Preprocessor. For problem is structural problem. You select the structural, then give the OK. Next preprocessor. Element type. Add add delete element. Add beam 188. You select beam beam 2 noded 188 element. Then you have to give OK. Close. Then material properties. Material model. Structural, linear problem. These things and all you know already, the analysis of the cantilever and simply supported beams. So similar kind of procedure should followed in same in this problem. Young's modulus 2.1 e power 5 Newton per mm square. Okay, so don't know in the inside don't have any units, but you will convert in the outside of the manually. Then you have to feed the Young's modulus 2.1 into Newton per e power 5 Newton per mm square, and points Poisson ratio is 0.3. Okay, so give the OK. Next, close the material properties. Then section beam, cross section of the beam. So your width is 110 mm, 10 cross 10 is your square beam. Okay, so this is give the OK. Next, look at the model. Create key point, inactive coordinate system. First you apply first key point 1, x direction y direction, x0 y0 z0. Then apply. Second, create key point 2. So this mm is 1000 mm per length of cantilever beam. So give the key point 1 and then key point 2. Okay, so create a key point 1 and key point 2. This is 0 comma 0. This is 1000 comma 0 comma 0 second key point. Okay, next one, create a line, form a straight line. Okay, so first select your first key point and then second key point. Okay, click OK. Then you have to move loading options. So go for load, load, define loads, apply, structural, displacement. We have only for key point and lines. Then we have to select the key point. This end is fixed. Okay, so your cantilever beam key point 1 is fixed. You would select the all degrees of freedom, you fix. Suppose you select the simply supported beam, so this is a deselect the all degrees of freedom, only y direction only arrested, rest of the degrees of freedom is open. Okay, so this is the two category of our problem. So now I select the all degrees of freedom is arrested. First I do the cantilever beam of the problem, because I will select all degrees of freedom. Okay, so this all degrees of freedom is arrested. Then you have to go for mesh size control, manual size. You have only for line, so pick all the lines. Okay, so this is only one line in your domain. So this edge length is you give 10. Okay, So this is very fine. So that much amount of the fine is no need for your problem. We're going to 10. That is enough for your mode shape analysis. So this is the size control of the meshing. Then you have to mesh line. You select your line. Then you have to click OK. Okay. So your problem is meshing. Okay. Okay. So next, your numbering. Create numbering. Your node number and then element numbers. Okay, you will on this number you will select everything. You know the element and key points. Okay, then then you have the load set option, analysis type. You want this is where our problem is model analysis. Then analysis option. Our number of mode extension is number of mode extraction is 5. Okay, so we'll give the 5. Give the OK. Our frequency is starting from 0 to 100. Okay, so that is already given in your aim of your problem. So this is our conditions. Then you have to solve the problem. Sorry, solve the problems. Go to current ls. Okay, one data is missing. The data is given for elemental properties, material model, create density. Density is 7830 e power 7830 only. Okay, so that is given your problem. Okay, that was missing. So I will give the additionally added material properties. Then you have to solve current ls. Okay, your solution is done. Okay, close it. Then go for a result. So this is for some unique of this results. So previous problem you are going to plot result and contour plot will getting the result. In this experiment you are doing first set of the result. Okay, so select the read result, first set of the result, select it. Then you have to plot result, contour plot, nodal solution, deformation of the solution for y direction. Okay, so undeformed shape also. Okay, this is a first mode. Then you have to second mode, then third mode, fourth mode, then fifth mode. So this type of modes will form a cantilever beam. This noded diagram is uh, getting the printout. So hard copy, 2 files. So this is I will select a TIFF format. So that is TIFF or JPEG. So we will select the JPEG or TIFF. Okay. So now I select the JPEG format. Do the OK. So corresponding the directory you will mode shape is saving. So you will select the diagram. Okay. So then animate this picture, plot control, animate, mode shape. So this extract mode shape is 5 mode shape, deformed, undeformed shapes. You select deform and undeformed shape, then give it. Okay. So all the mode shapes are will animate. Okay. Then you will stop the animation, then close it. Okay. Thank you for everyone. Okay. This thing same for simply supported beam also. Okay.